Let me check whether it's working. Yeah, now the screen can work.
Yeah, from zako nisaidie kidogo. Saidia.
Okay, thank you so much for coming back. Thank you for coming back. You can re-invite your friends. Just re-invite them. Let me also bring my friends back. Let me also bring my friends back. Thank you so much for coming back. We are live again. I'm going to redo what I was trying to explain. I'm going to show what I was trying to explain. Okay. So we go back to number 10. This is where we stopped yesterday. Yeah, thank you for joining again. Remember to subscribe. Remember to invite our friends. Thank you for coming back. Invite somebody. Invite a classmate. Invite a schoolmate. Thank you. Yeah, I can see people are seriously back to the live stream. So I'm going to start with the first question today. That is number 10. Yeah, number 10. The question is saying that we solve for x in the equation. We solve for x in the equation 9, then 2 into 2x plus 2 minus 41 into 2x plus 8 equals to 0. So we're going to have 9. Then at this point, we apply a law of indices. Instead of writing 2 and power 2x plus 2, now we shall have it as, remember there is a law which says that a power m multiplied by a power n equals to a, then m plus n. So with this law, we can say that instead of 2 power, the addition of powers, now we break it to 2 power 2x, 2 power 2 minus 41, then 2 power x, not 2x, sorry, 2 power x then plus 8 equals to 0. So at this point now, we can say that the value of 2 power 2 is 4, and there is a 9 here. So at this point, we shall have 36. Then there is a 2 power 2x minus 41. Then 2 power x plus 8. There is also what we call the product law of indices, which says that in case we have a power m multiplied by n or raised to power n again, this can simplify to a power, the product of the two powers. So with that, we need to talk about now, at this point, we can split it to 36 into 2 power x. Then now power 2 is taken out there, minus 41 into 2 power x plus 8 equals to 0. This is equal to 0. Yeah. I can see people are still coming back. Thank you so much. Thank you so much. Remember to introduce yourself. Remember to say hi to your math teacher. Please invite somebody. I can see some people have gone, but we can bring them back right now. Yeah, thank you so much. We are now 60 and we are increasing. Thank you. St. Joseph's, I see you around. Okay, at this point now, remember this question we had not finished yesterday. The other time I started and my screen was not showing up. Now we can finish up and say that we need to say now, let 2 power x be something like t, so that we have 6, then t is now being squared, then 41t plus 8 is equivalent to 0. With this now, we can talk of the quadratic formula. You know how to solve using the quadratic formula when an equation is quadratic? For example, our unknown is t. So we'll be talking about t equals to the negative value of b plus or minus the square root of b squared minus 4ac. Then we divide by 2a. So at this level now we can substitute because the formula is direct. Negative, the value of b is negative 41. So we have negative 41 plus or minus the square root of 41 squared, because it's our b. Remember, when you square a negative power, the negative will even disappear. Therefore, writing it as negative 41 or 41, it's all the same. Negative 41 in brackets squared minus 4 into a, which is 36, times c, which is 8. Then now we divide this by 2 multiplied by 36. So we'll be having 41 now, plus or minus. Let me work out 41 squared. Then I subtract 4 into 4 multiplied by 36 multiplied by 8. 41 squared minus 4 multiplied by 36 multiplied by 8. This is giving us 529. So the square root of 529 is exactly 23. Now we will divide this by 72. At this point now, we can say that the value of x, or the value of t in this case, equals to 41 plus 23. Then we divide by 72. I'm getting exactly 8 over 9. Or the value of t equals to 41 minus 23 divided by 72. This is equal to a quarter. T is also equal to a quarter. Now with t equal to a quarter, we need to say that it is 2 power x that had been let to be t. So 2 power x equals 2. 2 power x equals to a quarter. One option is a quarter. And to solve this one, we shall say that 2 power x equals to, a quarter can be written as a half power 2. Remember that. A quarter can be written as a half power 2. Half power 2. Remember to invite a friend to this live lesson. Today it shall be great. It shall be great today. Thank you so much. Thank you, thank you, thank you. Yeah, recognize your school kindly. Be proud of your school. Tell us where you come from. Tell us where you come from. Okay. Okay. So this is going to be 2 power x equivalent to, instead of half, we can say that this is 2. We take the reciprocal and the power becomes -2. Remember the negative law of indices. So if we're saying now 2 power x is the same as 2 power -2. So the value of x can be concluded to be -2. Then we can also finish up by saying that there is another possible value, because we said t can also be 8 out of 9. So t equals to 8 out of 9. So 2 power x equals to 8 over 9. In this case, because 8 over 9 cannot be put to base 2, it can be put to base 2. Now, it means we can introduce logarithms. The log of 2 power x equals to the log of 8 over 9. And this means that x log 2 equals to the log of 8 over 9. And the value of x will be the log of 8 over 9 divided by the log of 2. I can see people are already typing the answer there. And we need it as negative 0.1699. Thank you so much. People are saying hi to their math teachers, and that is encouraging. All right. Now we go to the second question now. We go to the second question. The second question is telling us that in the figure below, triangle ABC prime is the image of triangle ABC under a rotation. By construction, determine the angle and center of rotation. To determine the angle and center of rotation, we are supposed to join, if it is A, we join A to A prime, A to A prime. We join A to A prime. Then we bisect the line joining them. We bisect the line that joins A to A prime perpendicularly. Perpendicularly, we bisect. I hope you are doing the same from your end. Actually, I'll be sharing this paper to some people. Make sure you print and work it practically. I'm just estimating a perpendicular bisector. Then after this, you can also join C to C prime or B to B prime, and you also bisect. So C to C prime, C to C prime, then we bisect, Once you bisect perpendicularly, you can see the two bisectors are meeting at a point. This now becomes our center of the rotation. A center, we can let it to be XY. Because there is no Cartesian plane, we are not in a capacity to read that value, but we can get the exact angle of rotation. So the angle of rotation, for us to get it, we need to connect A to the center, for example, and also the image of A to the center. So A to the center, and also A prime, the image of A to the center. To the center like that. Once you join them, now you can check the turn, because we have to join for us to rotate A to the center, then we turn to get A prime. So you check now this way of turning, and you discover that we are turning in the clockwise direction. Now that we are turning in the clockwise direction, the angle is negative. So you measure the angle. Let's say, for example, you've gotten 60. Now you write it as negative 60 degrees. This is the angle of rotation. There must be a sign behind it. The sign behind that angle is the one to tell us the direction of our turning. Thank you so much. I can see people are really following up. There was an issue with the other live broadcast, but I can see your people are back. Kitondo School, thank you so much. Lanet Secondary School, Nakuru, thank you so much. Moi Girls, Eldoret, well represented. Thank you so much. Share the paper. That must be requested through WhatsApp. You've seen our number. St. George's Girls. This is great. This is great. This is great. Thank you so much. Let's continue. Let's continue. I recognize our school and our math teacher, Beta I. Thank you so much. Thank you. Thank you. I believe now the work is decent and everybody can see from wherever they are. St. Mary's boys. This is great. Okay. Number 12. Points A, -1, -6, and B, -4, -5 are mapped onto A prime 5, -5, and B prime -1, -3, respectively, by an enlargement. Find the coordinates of the center of enlargement. Find the coordinates of the center of enlargement. The coordinates of the center of enlargement. It's good for you to know that assuming that we had a center of enlargement at some point here, then now we have the coordinate of A at this point, then A prime at another point. For us to get to the center, or for us to get the image of A, it should be noted that a straight line must connect the unknown set, which can be xy. So a straight line must be able to connect A and A prime to the center of enlargement, and the same should be able to happen for B, such that to the same center, if point B is at a point, B is at a point here, then B prime is at another point, they should be connected using a straight line to the center of enlargement. So we know A is -1, -6. A prime is 5, -5. Then B is -4, -5. Then B prime is -1, -3. I believe I put the coordinates well. Thank you, thank you. Rapogi boys, recognized. Baringo High School, recognized. Machako School, thank you so much. Kisumu Girls, Mark B, thank you so much. Thank you, thank you, thank you. Mr. Muthini Mark B, wonderful. Wonderful. This is going to be great. Now that we have been able to show that, even if it's good for you to know, even if the enlargement was having a negative scale factor, it would still mean that A and A prime are meeting at the center, B and B prime are meeting at the same center. That is something for sure. That is something for sure. That is something for sure. Therefore, we are now supposed to say that the line A prime and the line B prime are meeting at a point. And so we can find the equation of A prime, find the equation of B prime, then we solve their point of intersection. That one will definitely give us the center of enlargement. So the first thing to get is the first gradient. The first gradient is going to be, we can take change in x over change in y. That is going to be, we take -5 and we subtract -6. Then this must be divided by change in x. Because we started with -5, now we start with 5 minus -1. This is going to be a gradient of -5 plus 6 becomes 1. 5 minus -1 becomes 5 plus 1, which is a 6. So now this gradient can be expressed. 1 over 6 equals to change in y. Y minus -6, making it a positive 6, divided by change in x. X minus -1, making it a positive 1. Then we cross multiply to come up with the equation of the line. 6y plus 36 equals to x plus 1, because x plus 1 is being multiplied by 1. At this point, we can have 6y equals to x minus 35. That is the first equation. The other equation is equation b prime, whereby we can get the second gradient now in our case. This gradient is going to be change in y over change in x. So -3 minus -5. Then we divide by -1 minus -1 minus -4 minus 1 minus 4. Today we are going to be here -1 minus 4 minus 1 minus 4. So we shall have this one becoming a -3 plus 5, which is a 2. Then -1 minus -4, which is -1 plus 4. This becomes 3. So the second gradient is 2/3. Now we need to work with 2/3 and 1 coordinate. So we say the gradient of 2/3, let me work here, equals to change in y. So y minus -3, making it a plus 3. Then x, change in x, x minus -1, making it x plus 1. Making it x plus 1. At that point now, we can cross multiply and have 3y plus 9 becoming to x plus 2. Grouping like terms together, we can remain with 3y at this point and have 2x. Then we shall have 2 minus 9, making it a -7. 2 minus 9, -7. People are coming in. People are really subscribing. Wakili Matiliko, that must be Matiliko boys. Wonderful. Ngotofo West, that is wonderful. I recognize you. Bezema, wow, that is great. Precious Blood, I recognize you. Thank you for being around. Thank you for being around. Okay, let's continue solving this question. Today you are really motivated. So now from equation 1, remember equation 1 is here. Now we've gotten another equation 2 here. And we want to solve them simultaneously. From equation 1, we can say that the value of x is equivalent to 6y plus 35. So that now we can say 3y equals to 2 into, instead of x, 6y plus 35. We are substituting. We are using the substitution method of solving simultaneous equations. So this shall be, we need to open brackets and have 3y equals to 12y plus 70 minus 7. 70 minus 7 becomes 63, but we can group the values of y together first, so that this becomes a 9y. When you take 12 minus 3, 9y. Then on the other side, we shall have 7 minus 70, or rather, the 63 that we are getting here becomes -63. So that we can say y equals to -7 when we divide 63 by 9. Yeah, -7. With the value of y, now the value of x will be very easy to obtain it. the value of x will be gotten very easily. So x equals to 6 multiplied by -7. Then we add 35. So 6 by -7. Then we add 35. This also becomes -7. And this is to mean that the coordinate of the center of the enlargement, which is described above, is going to be -7, -7. This is the center of the enlargement. So you connect the points to unknown center. You connect the points to unknown center. Then after that, you equate them now. You solve using the concept of equation of a straight line. We are getting back to our 100. Remember to invite a friend. Remember to invite a friend to this live broadcast. I'm also inviting a friend as I check what you're saying. Yeah, thank you so much. Remember to say hi to your math teacher. Send regards to your wonderful math teacher. Send regards to your wonderful mathematics teacher. Okay. We continue, number 13, on inequalities. Inequalities. Let me clear some space here. You can see people are still coming back to the platform, and this is great and encouraging. This is great and encouraging. Tonight, we must cover whatever we had purposed to work. Even if some minutes are lost, we shall get there. Don't you worry. Solve the inequalities, and hence list the integral values of x. And hence list the integral values of x. When the inequality has been given this way, we pick first of all the first in the pair of the simultaneous equations, or the simultaneous inequalities, sorry. The first one runs from the first term up to the term just before the second symbol of inequality. Then the second one will be starting immediately after the first symbol of inequality up to where we have the last term. So this will be the first inequality. Then the other inequality in the pair is going to run from 2x up to the last term. So we start with x plus 2 less than or equal to x plus 6. Then now the second one is starting with 2x plus 6 less than -x plus 8. You first obtain the pair like that. Then now we can solve, whereby we will say that less than or equal to 2x minus x. You know, we are bringing x to that side so that you may subtract. 2x minus x, we get x. Then 2 minus 6 becomes -4. This is the first simple inequality. We can also reduce the other one. We can reduce the other one, whereby we say 2x, we can now bring the -x to be added, and this will be 3x less than 8 minus 6. 8 minus 6 becomes a +2. So the value of x equals to 2 out of 3. Sorry, this is an equality. This is an inequality, less than 2, which can be said to be x less than 0.6666, and it can be rounded off to 2 decimal places. Therefore, After getting the second simple inequality, we can now move ahead to state the integral values. So from -4, and you can see that there is or equal to. It means the -4 is also included. So we begin with -4, then -3, -2, -1. Remember, 0 is an integral value. Please never leave out a 0. It's always an integral values. Then now, after 0, the next integral value must be 1. Decimals and fractions are not integral values. Therefore, that is the last integral value according to the limits that we have. Remember, our number is on the screen. That is what you can use to appreciate the work happening here. Through the same number, you can also request for learning resources. The equation of a straight line, L1, is given as 4 out of 5y minus 3 over 10x equals to 7. Find the gradient of line 1, line L1. It's good to know that for us to extract gradient of a line, we need to have the equation in the form y equals to mx plus c. In this format, the coefficient of x, which is our m, becomes the slope, or rather the gradient. So this will be our gradient. And if that will be our gradient now, then the equation has to be in the right format. The equation is supposed to be in the right format. So now we can begin by rearranging. We can remain with 4 out of 5y equals to, we take 3 over 10 to the other side, then plus 7. Now we can multiply by 5 out of 4. So that y remains alone by 5 over 4. So 3 over 10 by 5 out of 4 becomes, when multiplied by 5 over 4, it shall be by 5 1 by 5 2. So it will be 3 over 8 x plus 7 is also multiplied by 5 over 4, and it shall be by 5 over 4, we get 35 out of 4. In this case, we will say that the gradient of line 1 is exactly equal to 3 out of 8. 3 out of 8. So that is gradient 1. Find the equation of L2, which passes through to -3 and perpendicular to line 1 in the form ax plus by plus c equals to 0, where a, b, and c are positive integers. Very specific instructions, positive integers, which means you must carry out several rearrangements so that we may remain with positive integers. If the line is perpendicular to the above, then it should have a gradient 2 such that gradient 2 multiplied by gradient 1 gives us -1 for perpendicular lines. So we need it to be the reciprocal of 3 over 8 is 8 out of 3 with a negative sign. Now that the first gradient is positive, this one does a negative. So this is the gradient that we are expressing now. -8 over 3 equals to change in y minus -3, making it a plus 3. Then change in x minus 2. After this, we can cross multiply, meaning that we shall have 3y. Yeah, 3y plus 9 equals to -8 x positive 16. Now we can arrange the equation so that it may take the format which is described up there. So we begin with the x part, the part with x. That means it will come to this side and become positive. Then there is already 3y. Now we are having 9. We are having 9 at that point, which means we are supposed to subtract from 9 16. So 9 minus 16 is going to give us -17. Then we remain with a 0. our negative 17 is now our C, and there is no way C will become positive. So we will have to get the first value being positive, the second one also positive, but this one is not a positive integer, it's a negative 17. That is what we are having. Number 15. The displacement S meters of a moving particle after t seconds are given by S equals to t power 3 minus 9t squared plus 40t plus 8. Find the maximum velocity of the particle. Find the maximum velocity of the particle. It's good for you to know that at maximum velocity, acceleration equals to 0. When the particle has fully accelerated, then it has attained maximum velocity. So the first thing we are going to do, because we are given a displacement function, we will differentiate it first to get velocity function. So velocity function is given when distance is differentiated with respect to time. And this value is going to give us, the first term will be 3t squared, then minus, we drop 2, that gives us 18t, then plus 40. This one is the velocity function, and it must be noted to be the velocity function. After that, we go now to the acceleration function, whereby we are saying that for us to get acceleration, we have to differentiate velocity with respect to time, or rather, we carry out the second derivative of the distance function. The second derivative of the distance function. Thank you so much. Greet your math teacher. Recognize your school as we continue. Thank you so much. Invite a friend. Kindly remember to subscribe. Just remember to be a subscribed member of this platform. Tomorrow, come with a friend. It shall be greater. Tomorrow, it shall be greater. Come with a friend. Okay, the second derivative. This becomes 60 minus 18. Now, at this point, we will say that acceleration function has to become 0 for us to attain maximum velocity. So at maximum velocity, we say the acceleration equals to 0. So we will say that 60, which is the acceleration function, minus 18 equals to 0 at the maximum velocity. So that 60 equals to 18, and the value of t becomes 3 seconds at the maximum velocity. So the velocity itself now, because we have t at maximum velocity, then the maximum velocity itself can be obtained, which will be 3 squared. I'm using the velocity function here. Then minus 18 into t, which is 3, plus 40. Let's get the value of the maximum velocity. This will be 3 multiplied by 9, then minus 18 into 3, then plus 40. This is going to be exactly 13 meters per second. 13 meters per second. That is the maximum velocity attained. Remember to follow the instructions that I'm giving. Whatever I'm mentioning tonight is very important. Somebody says, teacher, you are wrong. No, you must check my work properly. I'm talking about displacement function has to be differentiated first for us to get velocity function. Then we differentiate velocity again for us to get acceleration function. We are saying that maximum velocity is only attained at acceleration being 0. When acceleration becomes 0, then velocity is maximum. Velocity is maximum. That one has to be interpreted in the right way, in the right way, in the right way. Thank you, thank you, thank you. Thank you, thank you. Somebody says 9 minus 16. 9 minus 16 is 7 and not 17. That person must be correct. Thank you so much. Yeah, thank you so much. We continue. Thank you, thank you. Can see people are very careful and keenly following. Thank you so much. Okay, stay here until we finish the paper. Send Bakita girls Kiangine. Wonderful. Continue following. Continue following. Given the position vector of A is 4i minus 2j minus 3k, and the position vector of B as negative 3i plus 4j plus 2k, express vector AB in terms of A, in terms of I, j, and k, and hence find the magnitude of the same vector. Find the magnitude of the same vector. What we're supposed to know is that for us to get vector AB, we are supposed to take B minus the position of A. This is going to be negative 3. I'm writing them as column vectors 4 and 2 from the position of B. Negative 3, 4, and 2. Then I subtract the position of A, which is 4, negative 2, negative 3. Then this is equal to minus 3 minus 4 becomes negative 7. Then 4 minus negative 2 becomes 4 plus 2, which is 6. 2 minus negative 3 becomes 2 plus 3, which is 5. So if this is the column vector of A, we can first of all express it as I, j, and k according to the instructions. So that we say vector A, B is equal to negative 7i plus 6k plus 5k. Sorry. J is coming first to represent the y components, then 5. This is now the vector expressed in terms of I, j, and k. After this expression now, we can find the magnitude of AB. We can find the magnitude of AB expressed this way. The magnitude of AB, whereby we need negative 7 squared plus 6 squared plus 5 squared, and we also obtain now the square root of everything. This is going to be, when I square and I add the other one squared, 5 squared, then I carry out the square root. This is going to give me, and we have been told to 1 decimal place, so it's 10.5. People to confirm, 10.5 exactly units. That is to 1 decimal place. To 1 decimal place. Thank you so much. Let's continue inviting our friends. We are now in section 2. We must cover a few questions in the section 2. We must cover a few questions in section 2. Thank you so much for being around. You people are great. Teacher, repeat number 15, please. I repeat number 15. I hear you. Number 15 is on what? Okay. This is a kinematics together with differentiation. We said, I'm just repeating the description of what you've done. When you take a distance function and you differentiate it, you get a velocity function. That is what I did in my first step. Now, from the velocity function, for us to get acceleration function, we have to differentiate again. So the second derivative of the distance function gives us acceleration function. Then now we are saying because we are finding maximum velocity of the particle. Maximum velocity of a particle is always attained when the acceleration is 0. If it is attained when acceleration is 0, then we will let the acceleration function to be 0 so that we may know that particular time when acceleration became 0, so that we may know at the same time velocity became maximum. Then now we obtain the maximum velocity by substituting the value of t, which is 3, in the velocity function to give us a velocity of 13 meters per second. Thank you for your question. Now we continue. We can be faster now. This is a section 2 question. This is a section 2 question. Complete the table below for the function. Complete the table below for the function y equals to 2x power 2 plus 5x minus 18 in the range -5 to 3. So we start in the function when the value of x is -5, then we go to the value of x being -4. We substitute in the function 2 into -4 squared. Then we add 5 into -4. Then we subtract 18. This is giving us exactly -6. So we have a -6 at that point. The next is a -2 because -3 has already been filled. So 2 into -2 squared plus 5 into -2 minus 18. You're just using your calculator to substitute. This is giving us -20. We substitute -1 now. Remember, filling this table is 2 marks, and you're just using your calculator and the function provided there. So we start with 2, open bracket, -1 squared, plus 5, bracket, -1, then minus 18. This is giving us exactly -21. -21. At 0, we have 18, negative. Then at 1, we shall have 2 into 1 squared, plus 5 into 1, minus 18. And I'm getting exactly -11. We have 2 into 2 squared, plus 5 into 2, minus 18. This is giving me 0. These are the values of y that we have. These are the values of y that we have. Thank you. Thank you so much. Thank you. Thank you. Thank you. People are also working out the values. I think this is great. This is great. This is great. We continue. Request from Emmanuel Muli on external vector 2013 number 8, please. I will attend to that question. I receive your requests from Gota Boys. Thank you. On the grid provided, draw a graph of the function above in the range provided. Use a scale of 1 centimeter to represent 5 units on the y-axis and 1 centimeter for 1 unit in the x-axis. In the x-axis. So remember, the largest value on the y-axis is 20, which is negative. Then there is a 15, which is positive. We are using 5 units to be represented by 1 centimeter. So we can do our Cartesian plane, x-axis, then the y-axis. The y-axis, the x-axis. You don't have to indicate that they are the y-axis and the x-axis. That one is implied. That one is implied. So we can now label according to the scale which has been provided. From 0, we'll have 1, 2, 3, 4. Then on the other side, -1, -2, -3, -4, -5, -6. We can go up to that point. Then we are using 5 now for each one square, so that we go to 10, 15, 20, 25. On the lower side, we can have -5, -10, -15, -20, -25. Yeah, we can go up to that point. Now we have the axis labeled. We can come up with now plotted coordinates. I can use a different color for that case. Let me come with red. -5, 7. So -5 is here, and 7 is going to be at this point. -5, 7 is at that point. The other point is -4, -6. -4 is here. -6 on the lower side is going to be at this point. That is the second coordinate. The other one is -3, -15. -3, -15. The coordinate is found here. -3, -15. Then -2 is going with -20. -2, -20. This coordinate. -1 is going with -21. So -1 and -21 are at this point. 0, 0 is going with -18. So 0 and -18, the coordinate will be found here. We have +1 going with -11. So +1 is here. -11 shall be found here. That is the coordinate. We have a +2. +2 going with 0. So +2 is lying on the x-axis like that. And finally, +3 and +15. For +3 and +15 at this point. So these are the plotted coordinates. We can already see the behavior of the curve even before we draw it. Allow me use a different color again for the curve. A different color for the curve. Let me come with green. So with green now, I'm going to do the curve. Remember, a curve is supposed to be smooth and continuous. Smooth and continuous. Smooth and continuous. This is the curve. It's supposed to be smooth and continuous. This is how you should come up with a very good curve. A curve which is very smooth. You just join your dots continuously. You join your dots continuously. Yeah, come up with your good curve like mine. That is my curve. You can comment on my curve kindly. Comment on how the curve is. Supposed to be smooth. Supposed to be very smooth. Very smooth. People are suggest questions on taxable income. That is what we are going to do. That is what we'll be doing from tomorrow, paper 2. That is what we will be doing tomorrow, mathematics paper 2. Okay. Use your graph to solve the equations. The first equation is 2x squared plus 5x minus 18. So for us to solve the equations, we are supposed to ensure that we subtract each of the equations from the original equation which has been plotted, so that we may come up with a linear equation. So we write the first equation, which was plotted, y equals to 2x squared plus 5x minus 18. Then the equation that we are solving is 0 equals to 2x. 0 equals to 2x plus 5x minus 18. Now we can subtract downwards the corresponding terms. If it is y, we subtract 0, we get y. Then 2x squared minus 2x squared becomes 0. 5x minus 5x becomes 0. Negative 18 minus negative 18 also becomes 0. So this side becomes 0. And you find that the straight line that we are getting is line y equals to 0, which is the x-axis. If it is the x-axis, this one is the x-axis. If it is now the x-axis, we look at the points where the x-axis is cutting the curve, or the curve cuts the x-axis. Those are going to be points negative 4.6. So x equals to negative 4.6, and also x equals to positive 2. Remember, at positive 2, the curve passes. So that is how we are supposed to solve such a question. That is how we are supposed to solve such a question. The other equation, we again subtract it from what has been plotted. Y equals to 2x squared plus 5x minus 18. Then we have a 0 equals to x squared plus 3x minus 10. Remember, the idea is to eliminate the squared part so that we may come up with a linear equation. So when you look at the part with x squared, when we subtract, it shall remain still squared. And so for elimination to work, remember how we used to do the linear simultaneous equations for elimination in Form 1 mathematics. So because the coefficient here is 2, but on the other side the coefficient is 1, then we shall multiply the whole of this equation by 2 and of the first one by 1, so that the first equation remains the way it is. Y equals to 2x squared plus 5x minus 18. But the second one becomes 0, equals to 2x squared plus 6x minus 20. And then we can now subtract to eliminate the squared part. We can now subtract to eliminate the squared part. When we subtract, we shall have y equals to, because y is minus 0, then now we will be having a 2x squared minus 2x squared becoming also 0. So that part now is done away with. 5x minus 6x becoming negative x. Then negative 18 minus negative 20. That will be negative 18 plus 20 becoming a positive 2. This is the linear equation that we are supposed to interact with. Now we're going to come up with a small table of values of x and y so that we may plot this kind of a linear equation, so that we may plot it. So this is going to be, we can have a x being 0, so that y becomes 2. When you substitute 0 in that equation, we shall get 2. Then we can go to the value of x being, let's say, even 2. When x will be 2, the value of y shall be 0, because that will be negative 2 plus 2 becoming 0. So now with this, we can plot our line 0, 2, 2, 0. Those are two enough coordinates. They are actually the intercepts. So we are using 2 and negative 2, or we can even add the third point. Remember, when you have 2 points, you cannot even know when you are wrong. but a third coordinate confirms that you are really passing on the line. So we can look at when x is -2, what shall be the value of y? So -2 becomes positive, so that when we add 2, it becomes a 4. So we are starting with a 0, 2, 2, 0. For the line, I can use a different color, like this one. So I'm saying we have 2, 0. So this is the coordinate. Then there is also 0, 2, whereby it's already there. Then the other one is -2, 4. -2, 4 is a coordinate at this point. -2, 4 is a coordinate at that point. So now we plot our graph. We draw our straight line so that it passes through the plotted coordinates. So the line is going to be here. That is the straight line. That is the straight line that we intended to come up with. Now we're going to look at the points where the line is cutting the axis. And we are saying for that second equation now, the values of x shall be +2. Yeah, because +2 is one of the values. Then the other one is -5. The values of x where the line is cutting. That is a -5. Yeah, those are the solutions. You can even use other methods of solving an equation like this, and you shall confirm that our values are very accurate. Very accurate. So you can read them from the graph. The line is cutting the graph at -5 and also +2. So those are the solutions. We can look at number 18, which is from Thank you so much. I told people to mention something about this curve. A good curve. Somebody says a good curve. Thank you so much. Somebody says eco-based. Thank you so much. Curviers, okay. Cubic curves. We can handle that in our next lesson. This is great. Somebody says a smooth curve. Class, keep quiet. Let's continue. Let's have our next now. Yeah, that is how a curve is supposed to be. Okay. Number 18. Given the matrix M equals 2, 3, 5, 1, 2, find M, the inverse of matrix M. For us to get the inverse, we are supposed to first of all obtain the determinant. The determinant is obtained by product of the elements in the leading diagonal. The leading diagonal is having 2 and 3. So 2 by 3. Then we subtract the product of the elements in the other diagonal. The other diagonal has 5 by 1. This means you'll be subtracting 6 and 5 to give us 1. So if the determinant is 1, then we can now obtain the inverse of this matrix, whereby for us to get the inverse, we interchange the positions of the elements in the leading diagonal such that 2 takes this point and 3 comes down here. Then after that now, the elements in the other diagonal change their sign or reverse their signs such that 5 becomes -5 and 1 becomes -1. Yeah, 1 becomes -1. Okay, at this point now, we are through with our inverse, because after doing that to the elements, we have to divide everything by the determinant. But as you can see, the determinant is 1. So the matrix now will remain just as it is. John bought 15 textbooks and 25 exercise books for a total of 10,000 Kenya shillings. If John had bought 10 textbooks and 20 exercise books, he would have spent 3,000 less. Take X to represent the price of a textbook and Y to represent the price of an exercise book. Part 1. Form two equations to represent the information above. So to represent the information above, we are supposed to say that 15 textbooks, so 15 multiplied by the price of each, which is X, plus 25 multiplied by Y, we are supposed to get 10,000. Then again, we know that if John had bought 10 textbooks, so 10 by X and 20 exercise books, 10Y, he would have spent 3,000 less. That means he would have spent 7,000. He would have spent 3,000 less, means that instead of 10,000, he would have spent 7,000. So this is now the two linear equations representing the above information. Use the inverse of M above to find the price of one textbook and one exercise book. At this point, we are supposed to know that the above linear equations can also be simplified to become, when you divide the first one by 5 through, you get 3x plus 5y being equal to, we're dividing by 5, so we get 2,000 at that point. Again, the lower one can be divided by 5 to give us 2x plus, by 5 we get by 5. No, it can simplify even by 10, sorry. I think 10 is a common, 10 is a common factor, sorry. 10 is even a common factor for the second one. This will become x plus 2y being equivalent to 7,000 over 10, becoming 700. These are the equations simplified. Equations simplified. All right. We are using the inverse that we obtained so that we may solve now this equation. That means we are solving the equation using the matrix method. To use the matrix method, we are supposed to come up with a matrix equation. What you have is a linear equation. So we make it a matrix equation by saying we extract the coefficients matrix 3, 5, 1, 2. That is the coefficients matrix. Then the variables matrix is xy equals to the constants matrix 2,700. That is called the constants matrix. At this point now, we are going to multiply or pre-multiply both sides of the equation by the inverse of the coefficients matrix. The inverse has already been obtained, so we just introduce it here now. 2, -5, 2, -5. Then we have -1, 3, -1, 3. At that point, multiplied by 3, 5, 1, 2. Multiplied by xy equals to, we bring it again here, we pre-multiply both sides, -1, 3. Then there is a 2,700 here. That is it. Yeah. So we can carry out now multiplications. It's good for you to know that the general knowledge of matrices helps us to know that a matrix multiplied by its own inverse gives us the identity matrix. So you don't even need to carry out the multiplication. You just imply that a matrix multiplied by its own inverse becomes the identity matrix. Then we have xy. This is equivalent to, now we can perform multiplication on the other side, whereby we multiply row times column. So 2 by 2000, 2 by 2000, then minus 5 multiplied by 700, and to add. This is giving us 500 at that point. Then we will have the other row now times the same column, negative 1 by 2000. Then we add 3 by 700. This is going to give us exactly 100. So now we are talking of a matrix on the left-hand side multiplied by the identity matrix, making the matrix to remain just as it is. Multiplying a matrix by the identity matrix makes it remain just the way it is. So xy remains xy because it's being multiplied by the identity matrix. 5 0 0 1 0 0, so that we may conclude that x is equivalent to 500, y is equivalent to 100. So those are the prices of a textbook and also an exercise book, respectively. Part C. John later sold a textbook at a profit of 20%. John later sold a textbook at a profit of 20%. At a profit of 20%. If we are selling at a profit of 20%, then it means that we can calculate the price at which a textbook is being sold. The price at which a textbook is being sold. Remember, a textbook is good for 500. So selling it at 20% means the selling price of a textbook now is becoming 120% of 500. 100%, 120% of 500. This is going to be, is it 600? Yes, 600. So now this gentleman is selling a textbook at 600. If John received a total of 11,875 from the sale of all text or all the books, find the percentage profit of an exercise book. So we shall say now, when we take 600 multiplied by the number of textbooks which were there, we are told that John bought 15 textbooks. So by 15, then we add a certain unknown. We add a certain unknown, and that will be the selling price of exercise books. We are supposed to get total sales. We are supposed to get total sales of 11,875. So the selling price of all the exercise books now can be gotten because we just need 11,875 and we subtract 600 multiplied by 15. This is giving us exactly 2875. 2875 as the selling price of all the exercise books. Remember, the exercise books were 25. The exercise books were 25. This means that the 25 of them are having sales equivalent to 2875. So when I take 2875 and I divide by the 25 exercise books, I'm going to get 115 Kenya shillings as the selling price. But remember, the buying price of an exercise book was at 100. Now the selling price is 115 for one exercise book, which means the profit was 115 minus 100, give us 15 Kenya shillings as the profit. So that now percentage profit becomes profit out of the buying price multiplied by 100. This is exactly going to be 15%. So we had a profit of, or John made a profit of 15% from the sale of an exercise book. From the sale of an exercise book, John made 15% profit. Thank you so much for holding on. Thank you so much. Thank you so much for being around. We are finishing up. We're just concluding our lesson. Remember to subscribe. Remember to share. Remember to invite a friend. Remember to invite. Remember to invite a friend. This is great. We can get to number 19. Remember, our number is still on the... Remember, my number is still on the screen. You can use it. Okay. The figure below, which is not drawn to scale, represents a flower garden, PQR, in which PQ equals to 8 meters. As you can see, QR 8 meters, and the angle QRP is the angle at this point is 35 degrees. Point S lies on PR such that QS equals to 6 centimeters, and the angle QSR is obtuse, an angle greater than 90 but less than 180. Okay. Find correct to 2 decimal places the size of angle QSR. The value of that angle. We can use what we call the sine rule. Following triangle QSR, then we shall say the angle there is S, but the side here is small letter s. With R here, the side is small letter r, but the angle is capital R. With Q there, the opposite length is Q, but the angle is capital Q. So according to sine rule, we can say that the angle at S, which is capital S, and the opposite length, the length S divided by sine of the angle S will be the same as, we can use R now, the length R divided by the sine of the angle at R. And when we apply some substitution, then we will say that 8 divided by the sine of the angle at S, which is unknown, will be equal to R, 6, divided by the sine of R, which is 35. Therefore, at this point now, we can say 6 multiplied by the sine of S after cross multiplication equals to 8 multiplied by the sine of 35. To remain with the sine of S, we need to take 8 sine 35, 8 sine 35 divided by 6. This is going to give us 0.7648. And at this point, we can get the value of the angle at S by obtaining the sine inverse. The sine inverse of 0.7648. This question is not even very simple, because after we get the sine inverse, the angle is going to be 49.89 degrees. But remember, this is an acute angle. 49.89 is an acute angle, and the angle there is supposed to be obtuse. Therefore, there is another angle whose sine is just the same as what we have obtained the sine rule for, and that is when we take 180 and we subtract the angle provided there, 130.11 degrees. We have been told to an accuracy of 2 decimal places. Therefore, the angle is 130.11. 130.11. We are winding up. We need the length of PS. The length of PS. Remember to subscribe. Remember to subscribe. Remember to subscribe. Remember to share with a friend. Remember to be here tomorrow for another live broadcast. The length of PS. Let's look at PS. So the length of PS, it's good for people to know that the angle at this point, okay, those two sides are equal. They are both 6. So that means the two angles here, the angle at this point and the one here, are also going to be equal. And that being a straight line, it means the angle at that point is going to be 49.89. 49.89. Therefore, if the angle is known, to be 49.89, then we can also conclude that the other one is also 49.89. 49.89. And again, okay, PS, yeah, the length is there. So with all these angles, we can also get the other angle at this point, whereby we need to say that 180 minus 2 multiplied by 49.89, this is giving us 80.22. So the size here is 80.22. There can be several methods of getting that length, but the length PS can now be gotten by, when I use 6 divided by sine rule again. 6 divided by the sine of 49.89 to be equal to the unknown length, PS, divided by the sine of the angle that I'm having here is 80.22. 80.22. Now PS, the length PS can be gotten by, we just cross multiply by sine 80.22. So 6 multiplied by sine 80.22, then we divide by the sine of 49.89. This is giving me exactly 7.73. 7.73 meters. I'm sustaining the accuracy according to the examiner, an accuracy of 2 decimal places in each particular case. 2 decimal places for each case. Yeah, thank you so much for following. Somebody says, sir, you are doing a great job. We are following. Thank you so much. Okay. The length of SR. The length of SR. Let us look at SR. Again, for us to get SR, we can use several approaches. Remember, the angle here is 130.11. So the remaining angle at Q can also be determined when we take 180 and we subtract 130.11 plus 35. The remaining angle now becomes 14.89. So the angle here is 14.89. With that angle as 14.89, and we want the length Q, then you see the length Q divided by the sine of 14.89. This will be the same as, now we can use any other length. For instance, we can use 6 out of the sine of 35. So that remain with Q. We need to work 6 multiplied by sine 14.89. 6 times sine 14.89 divided by the sine of 35. This is going to be exactly 2.69 meters. 2.69 meters. So with 2.69 meters, yeah, 2.69 meters. Now we are finding the area of the flower garden PQR in hectares. The radius of the flower garden. Okay, we can use several approaches, but we see that PS has already been determined. PS 7.73. And now at this point, we are having 2.69. So the total length PR is going to be, we add 2.69 plus 7.73. This is going to be 10.42. 10.42. Now with the length PR and also QR, then we have the angle in between those two lengths. We can use area of a triangle is given by half AB sine theta, whereby AB are two lengths, then sine theta is the angle between them. Therefore, we can take half times 8 multiplied by the other length that we are getting is 10.42. Then sine, the angle between them is 35. So the sine of 35, half multiplied by 8 multiplied by 10.42, the sine of 35. This is going to be 23.91. 23.91 square meters. But now I'm going to use the answer in my calculator so that I may divide all this by 10,000. 23.91 square meters. This one can be divided by 10,000 for me to get the answer in hectares and in 2 decimal places. So it can be 2.39 times 10 power negative 3 hectares. Okay, I can write in standard form, or we can make this one 0.00239 hectares. Yeah, which can simplify to 0 point, because if we don't write it in standard form and we write it to this value, then it means when we will be writing to 2 decimal places, we will have to write an answer which is equal to 0.00, which is not logical. 0.00 will not be logical. So we can even leave the answer in standard form. That way, it will be better. It will be better that way. It will be better that way. Thank you so much. Please remember to subscribe. Remember to subscribe. Remember to invite a friend. Remember to invite a friend to this broadcast. You are really doing a great work. A great work. Okay. Now we continue. Number 20, we can end there, or even in the next question, at least we will have done the first five questions. We will have done the first five. The frequency table below shows the daily wages paid to casual workers by a certain company. So the wages are in classes, as you can see. Calculate the mean wage. Calculate the mean wage. For us to calculate mean, the mean of X, now we need to get summation of f of X divided by summation of F. And so the first thing to get here can be the midpoints. The midpoints X, you can get the midpoints of each of the classes shown there. So the midpoint of the first class, when we take 300 and we add 350, then we divide by 2, we are getting a midpoint of 325. Now that we want f of x also, at the same time, we can be multiplying each value of f with the corresponding frequency. So the corresponding frequency is 140, the number of workers. So I'm having 45,500. 45,500. The other midpoint, when I take 350 and 450, then I divide by 2, I'm getting exactly 400. So 400 by 120, the frequency there, I'm getting 48,000. Then 450 plus 500, I divide by 2. We use the limits over 2, 475. Then this one must be multiplied by 380 to give us 180,500. The other one is going to be 500 plus 550 divided by 2 to give us 525. Then by a frequency of 240, this will give us 126,000. 126,000. Then 550 plus 650 divided by 2, a midpoint of 600. Then now we multiply this by 120 to give us 72,000. So these are the values of f multiplied by x. So we need to talk about now, let me check what is happening here. Yeah, thank you. I can see people are still following. This is great. Watu wasome. Okay. Now we are going to add so that we may get f of x. We shall add all the values. We shall add all the values. When we add, let me calculate a sum of f of x at this end. Sum of f multiplied by x. I'm getting 45,000. Then 45,500 plus 48,000 plus 180,500 plus 126,000 plus 72,000. Yeah, so I'm getting 472,000. So we have to divide by the total frequencies now. Total frequencies can be gotten by 140 plus 120 plus 380 plus 240 plus 120, giving us 1,000, a frequency of 1,000, total frequency of 1,000. So when we divide by 1,000, I'm getting 472.00. This is the wage. The mean wage should be in Kenya shillings. This is the mean wage now. That is the mean wage. The mean wage. We can continue finishing up. Continue finishing up. On the grid provided below, draw a histogram to represent the above information. For us to draw a histogram, there are several things that we are supposed to consider. One, we consider, is the data having equal class intervals? If no, then we are going to use what we call frequency density. If the class intervals are the same, then we shall use frequency against the limits. But for this case, where frequencies are not, where the intervals are very different, the intervals are varying, they are not uniform, then we shall calculate frequency density. Remember, frequency density is given by frequency out of class width. So each frequency divided by the respective class width. Each frequency over the respective class width. Frequency over class width. We are going to get what we call frequency densities. So now we start with the first frequency is 140 divided by the first class interval or class width of 50. This is going to give us 2.8. The next one is a frequency of 120 divided by a class width of 100, giving us 1.2. Class interval or class width is when we take the upper limit minus the lower limit, or the upper boundary. And in this case, because the data is continuous, the upper boundaries are also the upper limits. We are having a 380 divided by, I can see a class width, which is equal to 50. So we are getting a, equal to 50, so 7.8. 7.6, sorry. 7.6. Then from there we take 240 and we divide 240 by a class interval of 50. That is giving 4.8. 4.8. 120 divided by a class width, which is equal to 100, from 550 to 650. 100 giving us 1.2. So we have the frequency densities now. We have the frequency densities. We are finishing with this one. So stay around. Yeah. So now we can plot now frequency densities against the upper limits. Remember, the frequency densities are going all the way to 7.2. And so 7.6. So we can use intervals of 1 in the vertical axis. Intervals of 1 unit for each square. 1 unit of each square. So that can be a favorite scale. Yeah, to 7.6. All the way to 7.6. All the way to 7.6. So now we are starting from 0. Remember, frequency density is on this column. So from 0, we shall go to 1, 2, 3, 4, 5. Yeah, see. I'm charging my pen from Yeah, we have 1, 2, 3, 4, 5, 6. We can also have 7 and 8. We can also have 7 and 8. 6 is here. 7, then 8. Yeah, that is a very good interval. Then for the x-axis now, where we have the wages, we can start with the least boundary of 300. Then we go all the way to 650. We can even use intervals of 50. Intervals of 50. So from 50 all the way to, from 300 all the way to 650. So let me start with the first one. Start with the first one, and I'm going to have it as 50, so that I go to 100. So 300, the least one. The least one is 300. The intervals are the ones of 50. So 350, 400, 450, 500, 550, 600, 650. So these are the intervals that I'm going to use. You can also write 700. With these intervals now, I'm going to have the first class between 300 and 350. Then the height is 2.8. The height is 2.8. So a height of 2.8 is going to be up to this point. 2.8 up to that point. We can draw a line. We can draw a line like that. That is the first class. The second one, from 350, we are going all the way to 450. The height is 1.2. So with a height of 1.2, with the height of 1.2, with the height of 1.2, then all the way to 450. That is how the class is going to be. Remember, the classes are having different widths. Different widths. The other one will be from 450 to 500. It is 7.6. To 500, the height is 7.6. So 7.6 is at this point. At this point. Now we draw our bar to represent that class. So that is how we're going to have it. The next one, we're going to move from 500 now. From 500, we shall move all the way to 550. The height is 4.8. The height is 4.8. So a height of 4.8 will be at this point, 4.8, all the way to 550. So how the class is going to be. Remember these bars for the histogram, you can either shade them or not. You can just leave them plain as long as you have indicated their heights very well. The other one is going to be from 550 now. We are going all the way to 650. The height is 1.2. So a height of 1.2 all the way to 650. So a height of 1.2 will be here. A height of 1.2 shall be there up to 650. Up to 650 like that. Up to 650 like that. So that is the histogram now representing the data. That is the histogram representing the data. The histogram representing the data. Then there are some questions after this histogram. The first question says, state the class in which the median wage lies. State the class in which the median wage lies. The class in which the median wage is going to lie. So what we are going to do is that we are going to state what we call the cumulative frequency column, CF. The the cumulative frequency, in this case it is a row, the cumulative frequency row, whereby we list all the CF, the cumulative frequencies, such that the first one is 140. Then 140, we add the next, which is 120. That takes us to 260. 260, we add 380, and that will give us 640. 640, we add 240. That is going to take us to 880. Then when we add 120, we shall find ourselves at 1,000. Now with 1,000, we have to divide it by 2, because the median is the mid value. So we shall observe the class which contains the 500ths worker, 500ths value. So when you look at the cumulative frequencies, by the first class we have only 140. By the time we're in the second, we have 260. In the third, we have 640, and that is where the median is going to lie. That is where the median shall lie. So the class will be 450 to 500. 450 to 500. Class 450 all the way to 500. That is the class. That is the class where the median lies. That is the class where the median wage is going to lie. Then we are also told to draw a vertical line in the histogram. To draw the vertical line in the histogram showing where the median wage lies. Draw a vertical line in the histogram showing where the median wage lies. So for us to show where the median wage lies, we are told to draw a vertical line. Remember the number of people, we are looking at the 500s, the frequency of 500. Remember, the area of this bars is going to show us the number of people in the particular classes. This is what I mean. In the first class, we shall take the height of 2.8 times the width of 50 to get back our frequency of 140. So there is a frequency of 140 in this class. And in the next class, the height is 1.2 and the interval is 120. 1.2 and 100. So 120 people are here. Now in the median class, we will say that 140 plus 120, we are already at 260. With 260, and we want the area that represents 500. With the 260 and we want area representing 500, it means there is still area of 240, which is supposed to be added. So for the area of 240, now we shall get it in the next class, whereby we are going to say there is a constant height of 7.6. There is a constant height of 7.6. We should multiply it with a certain width, which is not known, for us to get the area of 240. So the width is going to be, when we divide 240 by 7.6, we are getting area, a width which is equal to 31.58. 31.58. So we intend to add 31.58. Now, when I look at the scale used on the horizontal axis of a small square for 10 units, then it means this is going to be 10, 20, 30. So that is where the line is going to lie. Remember, we are estimating. So the line is going to be there. The line is going to be there. This is the line showing the median. If that is the line showing the median, and we are just showing where it lies, remember we are through with that. But the median itself, if we were told to determine it, then it will be 450. Remember, from 450, we have added 31.58. So the median is going to be 481.58. 481.58. The same median can also be calculated using the mean, the median formula. That median is given by lower boundary plus total frequency over 2 minus cumulative frequency before divided by frequency of the class multiplied by the class width. Can we confirm this? That the same median from the histogram can also be gotten using the formula. The class is 450. And remember, this is continuous data. So whenever you have a boundary, it is also the limit. So the boundary of the limit of 450 is also the boundary, plus n over 2 becomes 500, because 1,000 over 2 becomes 500, minus cumulative frequency before this class. Before this class, there is a cumulative frequency of 260. So minus 260, then divided by frequency for the particular class, which is 380. 380. Then multiplied by a class width. Class width for the median class of 50. So when we carry out this computation, we're going to have 500 minus 260, then I divide by 380, then I multiply by 50. I'm going to have 31.58. So that when I add my 450 there, I will confirm 481.58. So this is the median according to the formula, and it's also the median. It's also the median according to the frequency, not the frequency, but the histogram. So from the histogram, we are getting the same formula that we also get when we use the formula. Using the histogram, determine the number of workers who earn 500 or less per day. 500 or less per day. So 500 or less per day, we are going to see where 500 is. 500 is here. This is where 500 is. So when we talk of 500 and less, it means now backwards. So up to this class, we will be having there are 380 people in this class, according to the frequencies. Therefore, we will add 140 plus 120 plus 380, and that is going to give us 640 people. So for this question, we will have 640 people. 640 people. Thank you so much for being patient. See you tomorrow for a continuation. Thank you so much. Good night.